We're going to be looking at this code, and the instructions again are a little bit unclear, but we are going through this and we're going to explain everything. So we need to implement a method that calculates area for classes that are derived from concrete class or abstract shape. And this is like give method that calculates an area for a triangle and a circle and a square. So what I'm going to do is I'm going to start off making triangle, circle, and a square. So the first thing I did was make these classes: class triangle, class circle, and class square. We could do these in different files. I would recommend that. I'm only just doing it in here so we can show everything at one time. So now that we have our triangle, circle, and square all made, we know that they're derived from our abstract shape. We're going to get into what the concrete is later. Since it's derived from our abstract shape, well, let's make our shape class. We have public abstract, because that's the class type, so it goes in front of our class, and then it's shape. The reason why it's public is because it's just our main file, or it's the main class in this file. If we had multiple different files, Java files with our classes, we would have public in front of these too, like public class triangle. But you only have one public class per file. With that, we have our class shape. We can extend the shape for all of these. So shape is extended for a square, circle, and triangle. That means we can use anything inside of here inside of our classes. So what we're going to do is we're going to calculate this. So we are going to have length, width, and radius, since we have a triangle, circle, and square, and those are the things that we need to calculate the area. So let's start off with our shape first. In our public static void main, we are going to make an instance of shape, triangle, circle, and then we're going to print these once we call the area. Notice how you have square.area, circle.area, triangle.area. We do this because if we want like a circle.circumference, we could easily implement that method too. And we would use the parent method and the extension. So the extension and the class. So we're passing in these variables into our square. Looking at our square, we know we have to pass some variables in, and we want to pass it to our parent method. So what we're going to do is we have this constructor that takes it as soon as this is created. Remember, a constructor runs as soon as this happens. So we're going to take this inside of our square, right here, this constructor. Inside of our constructor, these parentheses, we are going to do the super, where we pass it into our shape, because we extend this shape. So we do super, length, and width. Now, this is a constructor inside of our shape class. So we make this right here: public shape, double length, double width. And then we have this dot length, this dot width. It's storing it inside of these doubles. So now that it's inside of here, we can have this area right here. It's going to calculate it for us. So in our calculations, we have length times width. And that's going to give us the shape for a square. And all we need to do then is call the square.area, because that is what we have here, the double area. Now we are going to override this, and it's going to be inside of here for the triangle and the circle, and we'll see why in a second. So let's look at the triangle. We're passing in a 3 and a 3. So we go to our triangle class. It extends shape. So we are going to take a constructor like how we have here, and then we're going to pass in our length and our width. So it's going to go into the same constructor. So for this instance, our length and our width are 3 and 3 now. And the length and the width is 3 and 3 here. We are going to inherit it, but we are going to override it here. The reason why we need to override it is to calculate the area of a triangle. We need to return the super.area divided by 2 for a triangle. So we get this area, length times width, divided by 2, and then we're just going to return this. And that's going to return it. Same thing for our circle. However, for the circle, we completely override our area right here. We don't even use it, because we're just going to do the math.pi times radius times our radius. Now, this radius in here, and for our area right here, for actually not for the area, but for our circle, this radius times radius should, I'm not 100% sure if it matters, but like how we have in our triangle, we have super.area, so that grabs the area from up here. We could do like super.radius, and it should work the same way. So we have super.radius, and then we have super.radius, and that should call it. Now, I don't think it exactly matters because of how the inheritance works, so I'm just going to take it out for here because it still works when we run it. And if we are to pass in like a different radius here, because we have these radiuses that are passed in here, so it's going to go into here, and that means it's going to translate in here through our abstract class shape. Like if we were to set radius, this dot radius is equal to, if we change this to, which means we're changing this to, let's say 5, and we were to run it, this should change our 50.26 to be 78.53, which means that these radiuses are changing with this, and that it has no, like with the, and that means it doesn't just rely on this, which is good because we want it to go through our super class. It's a little bit confusing, so we may have to go over it a couple times, but this super is going to push this radius into our class here and store it inside of here. Then we are going to use our public double area to then use our math.py and multiply the radius from here. So even though we don't use the area here, we are going to override it using this radius, and then we are going to print it out. And that is how we would go about doing this. So we have our class, we have our main classes, and then we have our abstract. And that is how we would go about solving for this.